Hello and welcome to a new video about applied control engineering. We tried in this applied series, we tried P controller, said it will not finish. We tried I controller, said it is not reacting at the beginning. This time we're going to combine those two things. This time we want to use PI controller. There's a video where I explain PI controller. Right now we're using again this little part here. So we are controlling the temperature of this metal part with the help of a Peltier element. It is described in another video about switching controllers. You can watch it if you are interested. Here I can adjust the set point. I will adjust the set point to 45 degrees, something like this. And here we are again at the recording. So currently we have 25 degree here, and the set point is 0. Well, one thing is I have limited the output to 0. So the output can only be the output of the controller, so the correcting variable, which we can see here, it can only be between 0 and 100%. How is the controller currently adjusted? Well, the integration time is set to 2.5 and the proportional factor is set to 6. This was the last values we have used in the previous videos. So I would suggest to try this simply. So I will trigger now the set point. We see the P factor immediately brings this to a high level. Immediately. And in the background also the I part is growing, I would expect. So we will see. Now the P part is being reduced, the I part is still growing, and now you see the P part is winning, because the I part is growing slower than the P part is dropping, so the actual correcting variable is dropping. But that's not a bad thing, right? Because we simply don't want to overshoot here. We want to go as fast as possible to the set point and stay there. This would be nice if we can reach this. Let's see how good our adjustments are. Right now it looks a little bit like we're slowing down. I'm not sure if this would be already correct to slow down as soon as we do here now. I think the proportional part is a little bit too high. You see, we're going pretty much down here. And this I guess is too much. Now we're going to see that the temperature is also dropping. We want to see that, right? We want to see that. Well, the form would be okay. Now, if we now would be at a perfect level, we would stay. So I think that the proportional factor is compared to the I part a little bit too high. So we can either select to reduce the proportional part, or to make the integrational part with a lower integration time a little bit more aggressive. What I see here now, I think we could try to make it a little bit more aggressive. Because the rise looks pretty gentle and it has a flat spot. I think it would be a good idea to try the I part to be a little bit more aggressive. So right now we have 2.5, so I would suggest to use 1.5. second less. Now let's watch this, how this is finished. Switch to 10 minutes. Because actually we would expect now the eye controller to really get rid of all parts. Here, this is also a pretty good indication what we see right now, that the proportional part is a little bit over representative, because right now we're going in the right direction. Yeah? The temperature is slowly increasing, yeah? And the heating is dropping. Yeah? However, in best case, if the heating is at the correct level, right now I think we are still too low with the heating. Yeah? But if the heating is at the correct level, it would be perfect if the temperature is rising, that the proportional part is dropping and the integrational part is growing at the same rate, and the summarized output is staying constant. Right now we do not see that. Yeah? Right now we see that the summarized output of P and I part is dropping already. So this means the proportional part, which is reduced because we are getting closer, yeah, is too high. Yeah? This is why we always see this going down. Yeah? And the integrational part cannot compensate this, because the difference is already that slow or small that it will not integrate too much. Yeah? So this is why we see this crawling here. Yeah? Yeah, definitely the iPad needs to be speeded up. We're not waiting. I will let cool this down, change the iPad to 1.5 seconds, and then we will see it will look different. Okay, so we're almost there. Again, 24 degree temperature. Okay, I readjusted the iPad to 1.5, K is still 6. Let's trigger and see what is happening. Trigger, heat. Yeah. Now the iPad should react much more than before. Okay, so we're dropping again. Huh? Let's see where we are going to. Still, I think. Did not hit, but it's looking much better than before. Now it's getting interesting. If the I part or the P part is still that dominating, so that we are dropping now, or if we are stable. Again dropping. So maybe the P part is indeed a little bit too high, so we will reduce it. I see this is optimizing, but however you should only tweak one value there, one parameter, not do adjustments all the time and then guess what is happening. Right now, well, if I now reduce the P part, also the I parts will react, because it takes then longer to rise, so the I part is automatically growing with it. Yeah, but you see, you can influence those things. You can, if we are looking at the last, try, it looks like that. This was the I controller itself. This was now the PI controller. Now now looks a little bit different. Yeah, this is a little bit higher, and also here, well, not too much difference, I would say. There is not too much difference if we compare those two pictures to each other, the live picture and this one. Yeah, here we're a little bit closer than here. Yeah, little bit different. What we notice is this here seems to be longer. Yeah, this is because the iPad is growing faster. Yeah, it moved already in the right direction. Yeah. However, the next step I would perform is that I'm reducing the proportional part, because I also do not want to have this, and yeah. Yeah, but this is optimizing. You see now, a PI controller is reacting fast at the beginning, and in the end we could tweak it that it is really reaching the value, the desired value. This will be then covered by the I part. The P part is reacting very fast, and the integrational part is then doing the rest. And those two things, P part and I part, need to be leveled. And this is exactly, this is the task. This is quite a task. Yeah? We could do it like we do with experience right now. Yeah? Or we can also look into, stability, into analytics. Yeah? We will hear about this, how we might control this. Yeah, PI controller. Now you know that it's working better than before, right? And why we are combining those two things. Yeah. So for this time, thank you very much for listening. Goodbye.